Section 8.3, Operations on Radicals. Our first objective is to add or subtract radicals. And so we start by looking at a pair of like terms right here. We know that 8x plus 2x is 10x because we're adding like terms. So when we add like terms, we add the coefficients, we leave the x part alone. Okay. Similarly, if two or more square roots have the same radicand, they're called like radicals. For example, if you have something like the square root of 5 and 7 times the square root of 5, those are like radicals because the radical portion is the same. That's also like -2 square root of 5, but it's not like, for example, say 5 square roots of 3. Okay, it's the radical part that needs to be the same. It's also not like the cube root of 5. Okay, the entire radical part needs to be the same. They're all square roots. They all have 5 as the radicand. Now, if we do have like radicals, we can add or subtract them just like terms. So 17 square root of 6 minus 2 square root of 6 is 15 square roots of 6. All right. Now, if they're not like 50 and 18 right here, we can't add them, but they might still be like. These radicals, notice they're not simplified. The square root of 50 can be rewritten as the square root of 25 times the square root of 2, plus, and the square root of 18 can be rewritten as the square root of 9 times the square root of 2. I know the square root of 25 is 5, so this turns into 5 square root of 2. Plus, I know the square root of 9 is 3, this turns into 5 square root of 2. So, they weren't originally like radicals, but by simplifying the radicals, I can see that they are like radicals. They're both something that has a term with a radicand of 2. So, 5 root 2 plus 3 root 2 is 8 root 2. This is one of the reasons we have for simplifying our radicals, to see if we can get like radicals with other things. So let's look at the next one. Okay, I start off with 2 square root of 45. 45 can be broken down into 9 times 5. Let's put that 5 with the x because neither one can be broken down further. Minus 2 times, and the square root of 20 can be broken down into 4 and 5. Let's keep the 5 and the x together because, again, that piece can't be broken down. Okay, so we're at 2 times the square root of 9 is 3 times the square root of 5x minus 2 times 2, square root of 5x, so 2 times 3, I've got the first one 6 root of 5x, minus 2 times 2 is 4 root of 5x, so 6 minus 4 is 2 root of 5x. Okay, and our last one here, we have 2 can't be broken up, but x squared can, so we're going to write this as 5 times the square root of x squared times the square root of 2 plus x times 18 broken down into 9 and 2. So we've got 5x square root of 2 plus, this is x3, I'll just write that as 3x square root of 2. 5x square root of 2 and 3x square root of 2 are like terms and like radicals. They both have an x to be like terms, they both have a square root of 2 to be like radicals. So I can add those up to 8x square root of 2. Objective 2, multiplying an expression with more than one term. Okay, so we're going to look at, when I take an expression like 5 times x minus 2, we distribute. Okay, so we're going to do something similar with our radicals. So when we distribute, we get 5 times x and 5 times 2, or 5x minus 10. Okay, same thing here in our expressions with radicals. We're going to distribute. 5 times this, that's a 7, sorry, 7 times the square root of 6 is 7 times the square root of 6. I don't multiply the 7 and the 6 together because one is outside the radical and one is inside the radical. 7 times the square root of 6 is simply 7 times the square root of 6. Minus 7 times the square root of 10. These radicals, radical 6 and radical 10, cannot be broken down. There's no perfect square that goes into either of them. So we're done. They're not like radicals. They cannot be simplified. Okay, let's go ahead and multiply the next one. 2 radical 3 times radical 12. Now, I can't multiply the 2 into the 12 because the 2 is outside the radical, but these are both in. 3 and 12 will multiply together to give me 2 square root 36 minus 2 square root 24. Okay, so we multiply the terms that are outside with any terms that are outside, and the terms that are inside the radical with any terms that are inside the radical. Now this could be simplified a little. So this is 2 times 6, right? The square root of 36 is 6, minus 2 times 24 can be broken up into 4 times 6. So this can be 2 times 6 is 12, minus, let me write a little bit smaller right here. Okay, so we've got 2 times 6 is 12, minus 2 times square root of 6. So I'm going to end up with 12 minus 4 square root of 6. Alright. And again, in part C, we're going to use the distributive property. We're going to multiply this whole thing all the way out. Starting with 5 times 6 is 30, plus 5 times square root of 2 is 5 square root of 2. Then square root of 2 times 6 is 6 square root of 2. And square root of 2 times square root of 2 is 2. The way to think about that last one again, square root of 2 times square root of 2 is square root of 4, or just 2. Right, when you have the square root of 2 squared, it gives you 2. Okay, so square root of 2 times square root of 2 is just plain 2, not square root of 2, just plain 2. Now, combined like terms here, 30 and 2 are like terms, so I have 32 plus 5 and 6 is 11 square root of 2. Alright, and the part D, starting off with 6 times 2 is 12. 6 times 5 root 7 is going to be minus 30 root 7. Alright, minus 3 times 2 is 6 root 7. And plus 3 times 5 is 15 times 7. That root 7 times root 7 is 7, so that's 15 times 7 for that last term right there. So we've got 12 minus 36 altogether, root 7, plus 15 times 7. Okay, so 5 times 7 is 35. Carry the, looks like 105. Carry the 3. Okay, so we've got 12 plus 105 is 117 minus 36 square root of 7. In objective 3, we're going to multiply conjugates. So remember that conjugates are a pair of expressions in which one is the sum of two terms and the other is the difference of the same two terms. So one's got the plus in the middle, the other has the minus. So like these two right here. 1 minus radical 6 and 1 plus radical 6, they're conjugates to the same two terms, but one's addition and one's subtraction. So let's multiply these conjugates together. Okay, 1 times 1 is 1. 1 times radical 6 is plus radical 6. Then I've got minus radical 6 and minus regular 6. Right, radical 6 times radical 6 is regular 6. So we see here that we have 1, radical 6 minus radical 6 is 0, minus 6, so negative 5. Okay, let's look at the next one. The next one's also a pair of conjugates. We've got 2 root 3 plus 7 and 2 root 3 minus 7. So 2 root 3 times 2 root 3 is 4 times 3. 2 times 2 is 4. Root 3 times root 3 is regular 3. Then we've got minus 14 root 3 plus 14 root 3. And minus 49. So 12, 14 root 3 and negative 14 root 3 add to 0. So we've got 12 minus 49 is negative 37. Okay. That's the end of the section. Okay, so one thing to note right here, while I'm multiplying these conjugates, if I'm multiplying conjugates with square roots, we can see just from these two examples that the square roots will always cancel out and our answer will always be integer. The only pieces that could possibly have square roots left in them are going to be those middle conjugate pieces that are opposites of each other, so they're going to add to 0. Okay, those are the only pieces that could be conjugates of each other, because when I multiply a square root by itself, that gives me a whole number. Okay, so that's our section.